right, in this lesson, we are going to be graphing systems of equations. But before we do that, I want to review how you would factor a quadratic equation. So the first thing that you always want to do is look for a common factor, the greatest common factor. So each of these has a factor of 2. So you want to factor that out. So then you would have x squared plus 4x minus 12. And remember with factoring, you factor until you can't factor anymore. So this trinomial right here can be factored into two binomials. So x times x gives you x squared. Now we want the factors of 12 here that have a difference of 4. So I'll list the factors of 12. And the ones that have a difference of 4 would be 2 and 6. Now you want to have a positive 4, so this will be a plus 2, or excuse me, a plus 6 and a minus 2. So plus 6 minus 2 gives you 4. So these are the factor, these are the factors here of this equation. Now, if I said to solve the equation, remember to find an x-intercept. The value of y is 0. So you put in a 0 right here. And if we were solving, the first thing we could do is divide both sides by 2, and this would cancel. 0 divided by 2 is 0, and then you have x minus 2 times x plus 6. Lastly, if this times this equals 0, we know that one of them has to equal 0 because 0 times anything is 0. So then to find the solution, the values for x, we set each of those equal to 0. So x would equal 2 and x would equal 6. What that means is that when y was a 0, x was a 2. So when y is a 0, x is a 2. When y is a 0, x is a 6. So these are 2 points on that graph. All right, let's get to the actual lesson here. So first, we're going to graph a quadratic that is in intercept form. Now, if you were to FOIL this back together, you would have an x squared, which tells me it's quadratic. So intercept form is factored form. It's another way of working with quadratic equations and graphing them. So what we do is we first find the intercept. So we set y equal to 0, and we can put an equal sign here because we're looking for actual points. And we can get rid of the 1/2. If you divide by 1/2, divide by 1/2, or if you multiply by the reciprocal, this just goes away because this would be times 2, which is 1, times 2, which is 0. So this will go away. So now you set each of those factors equal to 0. So x equals 2 and x equals negative 6. So in other words, when y is 0, x is a 2. So then you plot, this is the x-axis, you plot those intercepts, 2 and negative 6, right here. So these are the x-intercepts. Now it's quadratic. Oops, I got an extra line there. Let me get rid of that. It's quadratic, so these are your x-intercepts. So remember, we have an axis of symmetry, which is going to be in the middle of these points. There are a couple ways you can find it. You could count to see how far apart they are. 1, 2, 3, 4, 5, 6, 7, 8. And so if you divide 8 in half, you get 4. So if you count 4, 1, 2, 3, 4, it's right here. Let me do that with a different color. So this is your axis of symmetry, and I'm going to write that that is x equals negative 2. That's the axis of symmetry. The other way you could do it is you could take those actual points, 2 plus a minus 6, add them together, divide by 2. That's like how you find the mean value of those numbers. So that would be negative 4 over 2, which is negative 2. So the middle of those two numbers is at negative 2. Either way works. Now, we have the axis of symmetry. So how do you find the vertex? Well, we're going to plug it back into your original equation. So when x is a negative 2, we're going to substitute back into the original to find where the vertex is. So we have 1/2 and -2 minus 2 and -2 plus 6. So then you would have 1/2. Now remember your PEMDAS, you have to simplify inside the parentheses. So that gives us 1/2 times -2 is -2 times 4 is -8. So when we substituted in -2 here, out came a -8. So your vertex is at -8. 1, 2, 3, 4, 5, 6, 7, 8 right here. And I always like to see 5 points total. Right now we have 3. So let's plug in another number. You could plug in -1. Let's plug in 0. So if we substitute in 0, let me use a different color here, you would have y equals 1/2, 0 minus 2, and 0 plus 6. So that would be 1/2 times -2 times 6, which is -1 times 6, so that's a -6. So that would give you -6 right here. So now we have a point at 0, -6, which is here, and then reflect that over, and now you can graph. Oops, I'm going to go back 1 second here. This says it is greater than, which means it's not a solid line. It's going to be a dotted line. So there are a few ways to shade. You could test a point and see if it works, and then you would shade that. What I always do is when you have solved an inequality for y, I put my pen on the y-intercept, and it says y is greater. Well, if you look at the axis, going this direction, the y's get bigger. Going this direction on the y-axis, the y's get smaller. And so the y's are greater, so then it means that you're going to shade everything on the inside. And that's the answer for that one. So again, when you are in intercept form, and when I say intercept, I mean factored form, set each of the factors equal to 0, plot those points on the x-axis, and then you have to find the middle and draw a line, write down what that value is, substitute that back in, and find where your vertex is. And then just plug in one more point. All right, so here is an equation, y equals x squared minus 4x plus 3. And I actually have written it in all of the forms. First of all, standard form is when you have solved for y and you have the x squared, ax squared plus bx plus c. So guys, whenever we're working with standard form, I like to write down what your a, b, c values are. So in this case, it would be 1 is your a, -4 is your b, c is 3. And so we have to always need to start out by finding your axis of symmetry, and the formula for that is -b over 2a. So we substitute in the values, so minus a -4 over 2 times 1. That would be 4 over 2, which is 2. That is your axis of symmetry. Graph that line. X is equal to 2. So now we have to find our vertex. So what you're going to do is substitute that back into the original equation. So basically, I'm just going to make an XY chart so we can keep track of what we're plugging in here. So x is 2. So you would have 2 squared minus 4 times 2 plus 3, which is 4 minus 8 plus 3. -4 plus 3 is a -1. So there's your vertex. All right, and now we need some more points. So let's just pick some other values, some x values that are close to the line. We could pick any x value, but the points get really high or really low when we do quadratic. So let's pick numbers close, like -1 and x is 0. So if we plug in -1, not -1, how about, I will do -1. Let's do -1 here. It's a little further away, but let's do that, just so we can talk about negatives. When you plug in a negative here, all of x gets squared, so I always put parentheses around there. So that would be a +1, +4 plus 3, so that would be 8. So at -1, we're at 8. And that is 3 units away, so we're going to go 3 units on the other side. If we substitute in a 0, I'm going to erase a little bit here and put a 0 in instead. That's 0, that would become 0, those would cancel, you would get 3. So 0, 3, and that's 2 units away, so we're going to reflect it over, and there we have 5 points, and it says equal, so it's a solid line. All right. Now you notice the vertex for this is at 2, -1. And so this is the form of that same equation written in vertex form. Vertex form, you have solved for y, but notice you have a, which can be a 1, like in our case, x minus h. So you're going to see an x minus a number, and that whole quantity is squared, plus k. So whenever you see something in this form, that's called vertex form. And when it's in that form, the h and the k are the vertex. So these are actually probably the easiest ones to graph. So you write down, what is my hk? Now this says negative, so if this says negative, your h is actually a positive, and your k is a -1. So let me rewrite this in red, actually. And I'm just going to graph over and go through the process of how you graph when you're in vertex form. So we're going to go over 2, down 1, and you have a point. Now, the axis of symmetry goes through, so you will draw your axis of symmetry right down that line right there. And then you need some more points, so just make an XY chart and plug in some points. Like you could plug in 1, you could plug in 0. So if we substitute in the 1, we would have 1 minus 2, quantity squared. So this would be a -1 quantity squared, which is +1, minus 1, that gives you 0. So 1, 0, over 1, up 0, we have a point, reflect it over. And then we'll plug in 0. So let me erase. So if we do 0 minus 2, my pen is being very funky here. So this is a -2. And if we square that, we would get +4 minus 1. That would give you 3. So when I substitute in 0, I got a 3. So 0, 3, and reflect that over. It turns out same exact graph. So that was just in vertex form. So the first thing with vertex form is write down your vertex, plot it. You can draw your axis of symmetry then, and then just plug in some more points. Now, the next form we have is intercept form. Remember the original equation was x squared minus 4x plus 3. If you factor that, that would be 1 times 3 gives you 3, and minus 1x minus 3x gives you minus 4x. So this is the factored form of that equation. So let's do that one. Let's work with that one in blue this time. So again, when we're in intercept form, to solve, we set y equal to 0. And we set each factor then equal to 0. So x would equal 1, so that's an intercept. And x equals 3, that's your other intercept, and you plot the intercepts, 1 and 3. And now, once you know where the intercepts are, you draw a line right down the middle. And so that line is at x equals 2. And so, like if I make an XY chart, I'm going to substitute 2 into the original equation. So that gives you 2 minus 1 is 1. 2 minus 3 is -1. When you have this binomial and this binomial, the operation between them is times. So that gives you a -1. So 2 minus 1 is your vertex. And yep, that's what we got in all the other cases. And then you just need another point. So I would substitute in 0. So you would have y equals 0 minus 1 and 0 minus 3, which is a negative 1, times a negative 3, which is a positive 3. So 0, 3, and you get the same answer. So again, with intercepts, you set each intercept equal to 0 and plot those intercepts. Then you have to find the middle, draw a line, write down what it is, substitute that back into the original equation to find your vertex, and then just substitute in one more value. Okay, so that's a review of all the graphing. So now we're actually going to find a solution for a system of equations. Now, first of all, you have to identify what kind of equation, what kind of a line do you have? Well, this first one actually is in the form of y equals mx plus b. This is just a line. And the y-intercept is 6, and the slope is 1. So you're going up 1 over 1. And when we're solving systems, remember we want to see where the graphs intersect, so you have to graph very carefully. So you want to use a ruler probably. I'll use my little straight edge here, so I get a nice straight line. So there's that first one. Try to move it down just a hair. There we go. Okay, stay there. All right, now let's do the next one. So we have to identify what do we have going on? Well, it has an x squared. That means it's quadratic. And we're in the form of y equals ax squared plus bx plus c. That's standard form. So we'll write down ABC. And then we have to use the equation for the axis of symmetry to find that. Negative b over 2a. So it will be negative 5 over 2 times the negative 1, which is 5 over 2. That's actually 2.5. All right, so we're going to have a decimal, so we have to estimate then where 2.5 is. So it's like right here. That's the axis of symmetry. To find the vertex, we're going to substitute this in. Let me just make a little XY chart so we keep track of what we're plugging in. So when x is 2.5, you would have y equals negative, and I'll put parentheses around there. You have to do that because the negative is not getting squared, only 2.5 is. So this, I believe, is 12.25. I want to double check though. So you can type that in your calculator. Yes, it's 12.25. So when we substituted in 2.5 for x, out came 12.25. So we're going to go over 2.5 and up 12, 2, 3, 4, 5, 6. Just a hair up above. Right here is a vertex. Now we need some more points. So let's substitute in 1, how about? And 0. So if we substitute in 1, we would have negative 1 squared plus 5 times 1 plus 6. So this is a negative 1 plus 5 plus 6. So that gives us 10. So if we go over 1, we're up 10. Right here, and reflect that over. So, all right, and then we'll also substitute in 0. So 0 squared plus 5 times 0 plus 6, we have 6. 1, 2, 3, 4, 5, 6, and reflect that over. So this one looks like this. And now you can see our points of intersection would be at right here. And you write that down, you go over 0, up 6, and then over 1, 2, 3, 4, up 10. So that those would be the points that are your solution set for these two systems. All right, here's another one. We're going to graph a system of inequalities, which means that we have to shade. And this one is greater than or equal to, and so that'll be a solid line, and this is less than, so this will be dotted. Now the first equation, you have to look and say, okay, what form is it in? We have factors, and so you will set each of those equal to 0 to get the x-intercept. So if you add 3 to both sides, x would equal 3, x would equal -1. So you plot those on the x-axis, 3 and -1. So they are 4 units apart. So your axis of symmetry would be right here. And where's that at? That is at x equals 1. So the axis of symmetry is x equals 1. So we are going to substitute 1 into this equation. So you would have 1 minus 3 and 1 plus 1. So that's -2 times 2, which is -4. There's your vertex right there. Now we just need another set of points, so let's substitute in 0 into the original. We're always going back into the original, so 0 minus 3, 0 plus 1. So that would be -3 times 1, so this is -3. So 0, -3 is right here. All right, so now this, like I said, it's y is greater than or equal to, and so it's a solid line like this. And to shade, put your pen on the y-intercept, which is right here, and it says y is greater, so the y-axis is greater this direction, which means we're shading inside. And these are kind of hard to read when I do it in marker here, especially when I try to show you your overlapping. All right, next equation. This one, you'll notice, is in vertex form because you have this x minus 6 and this whole quantity squared. So your vertex is at +6, 3. So you always take the opposite sign in the inside there. So now we plot that. So we're going to go over 6 and up 3. So the vertex is right here for that one. And then remember, this is your axis of symmetry. That goes right through here. So now we need some more points. So we're just going to make a little XY chart. And let's just pick some numbers. Let me see here. If I pick, let's see, we have x is 6 already. Let's pick 3. And you could pick anything, but you may end up with decimals here with this. So we would have -1/6, 3 minus 6 squared plus 3, which is -1/6. This is -3, and if you square that, that'd give you +9 plus 3, which is 9 over 6, and that's 3/2 plus 3. Which is -1.5 plus 3, so that's actually 1.5. So if I go over 3, I'm up 1.5. So go over 3 right here. And then let's plug 0 in. So I'll erase so I have a little bit more room here. So instead of x, I'm going to substitute in a 0. So this would be 0 right here. So this would be -1/6. -6 quantity squared is 36 plus 3. So that would be 36 divided by 6, which is a -6 plus 3, and you get -3. If those are confusing, when you do your substituting, just type everything into your calculator, parentheses and everything. So now we have a point at -3. So this is 6 units away, so we have to go 6 units on the other side. So that is opening down, and that is a less than, so that is going to be a dotted line. And if you put your pen on the y-intercept, it says y is less than, which is this direction on the y-axis. So you're going to shade everything inside here. So here's the thing. The overlapping will happen right in here. So this is what's actually going to be the solution for that. All right, you have a worksheet to work on, and I'm going to work out just a few of the problems for you. On the back, you have y is greater than negative, and then the quantity x minus 3, x plus 3. So ask yourself, what form is it? Well, you have factors, so that's intercept form. So you set those equal to 0. So x would equal a plus 3, x would equal a negative 3 when you solve. So your intercepts are actually at 3, y is 0, and at negative 3 when y is 0. So plot those. The axis of symmetry will be in the middle. If you count 1, 2, 3, 4, 5, 6, it's 6 divided by 3 is, 6 divided by 2 is 3. Break it in half, so you have to go over 3. So your axis actually is a vertical line, so it's an x equals 0. Now we have to find the vertex. So we know that the x value of the vertex is 0. So we're going to substitute that in. Let's make an xy chart to keep track of what we're substituting in. So we'll substitute 0 in. Make sure that negative's out front. Don't forget about that. So that is a negative 3. This parentheses has a positive 3, so that's a negative times a negative is a positive. 3 times 3 is 9. So the vertex is at 0, 9. And now we should have one more point. So let's substitute in 1. So y would equal negative. So that's a negative 2. And that is 4. So that would be a positive 8. So now we have a point at 1, 8, and reflect it over. And it says y is greater, which means it's a dotted line again. Put your pen on the y-intercept. Y is greater is this direction. So you are shading everything around it. And there's the answer to that one. Now we have a system, and I'm not going to work this one out all the way, but number 3, it says y is greater than x squared minus 6x. Now there are a number of ways you could do this. You could factor it and work at it as it is in intercept form, or you can put it into standard form. So if you look here, we have the x squared term, we have the x term, but we don't have a c, so just put a 0 here. So then when you write down your a, b, and c, you would have 1, negative 6, and 0. And then just go ahead and do the axis of symmetry, x equals negative b over 2a. This next one, you don't have a plain x term, so write 0x minus 1. So here, your A, B, C would be 1/4, your B is 0, and your C is negative 1. So now you can work with these, you can graph these two equations. So for both of them, do x equals negative b over 2a. And then on the last one I want to talk about, we'll do number 1 together, actually. So the first equation, it is a linear equation because you have a y equals mx plus b form. So the y-intercept is 1. The slope is 2 over 1. So up 2 over 1. And just, again, we're looking for the intersection, so graph very carefully. And now we'll do the next equation. So this is a quadratic, and it is in standard form. So we write down ABC. So A is negative 1. I'm talking about this point here. Your B is 2, and your C is 1. So we're going to find the axis of symmetry. So it would be negative 2 over 2 times a negative 1, which is negative 2 over negative 2. So that axis of symmetry is at 1. Let's put that in a different color. So your axis of symmetry is at 1. So let's substitute that in and see what we get. So we'd have negative 1 squared. Remember that negative is outside the parentheses. It's not getting squared. So that's negative 1 plus 2 plus 1. So that's 1 plus 1, you get 2. So here's the vertex. You have to graph carefully or it looks like it's intersecting the line, but it's right next to the line. So now we'll substitute in 0. So then we would have 0 squared plus 2 times 0 plus 1, we get 1. Oh, here's an overlapping point right here. And let's substitute in, let's see, 0, 1, 2, let's substitute in 3. So negative, and we'll put 3 in parentheses. So that's negative 9 plus 6 plus 1. So that's negative 3 plus 1, that would give you negative 2. So if I go over 3, I'm down 2. So this one looks like this. So the point of intersection is just this point right here. It's at 0, 1. All right, that's it for this lesson. Let me know if you have questions. Thanks for watching.